There's that question that kind of hangs in the air for a lot of us.
Mm.
How do we really protect our brains as we get older?
Mm-hmm.
We hear about, brain games, staying active, diet, all good stuff.
They're fairly important pieces.
But today, we're doing a deep dive into something maybe more fundamental, something that might build your brain's resilience way earlier than you think. Education.
Right, going back to those formative years.
Exactly. We're digging into this really fascinating new study. It's called The Protective Role of Education in White Matter Lesions and Cognitive Decline.
Yes, by Elkanah and Beheshti, using the ADNI data, right?
That's the one, in collaboration with the Alzheimer's Disease Neuroimaging Initiative.
A really valuable data set.
Absolutely. So our mission today is to pull out the key insights from this research for you. And it's not just about education helping you sort of cope better.
No, it's hinting at something deeper.
Yeah, it suggests it might actually physically reduce some brain changes linked to decline, especially if you're maybe in an at-risk group.
Which is a pretty significant claim.
It really is. So get ready, because some of this might genuinely shift how you think about long-term brain health.
Okay, so to really get into this, we first need to talk about a key concept, cognitive reserve, CR.
Cognitive reserve, right.
What's so fascinating about CR is it's basically your brain's ability to be flexible, to optimize how it works, even when there's some underlying damage or pathology.
So like finding a workaround.
Exactly. Think of it like your brain finding a clever detour when there's a roadblock. It gets the job done using different strategies or networks.
Okay, and how does that differ from, I've heard, brain reserve?
Good question. They're related but distinct. So cognitive reserve is that functional flexibility. Brain reserve is more about the physical structure, like having a bigger brain volume or more neurons to begin with. It gives you more tolerance before symptoms show.
More physical buffer, kind of.
Precisely. And then there's a third piece, brain maintenance. That's more about the active things we do, lifestyle factors, health choices that actually reduce or slow down the buildup of that brain pathology over time, like, managing blood pressure, not smoking.
Got it. So CR is the flexible strategy, brain reserve is the hardware buffer, and maintenance is actively preventing the damage.
You've got it. A helpful framework.
So in this study, what physical changes were they actually looking at? You mentioned white matter lesions, WMLs. We hear about those a lot with aging. What are they exactly?
Right. WMLs are absolutely central here. Think of them as visible signs of wear and tear on the brain's internal wiring. The white matter tracks connecting different regions.
The communication cables.
Exactly. On an MRI scan, they show up as spots. Sometimes bright spots called hyperintensities, often linked to small blood vessel issues.
Okay.
Or sometimes darker spots, hypointensities, which might mean more significant injury, like damage to the nerve insulation or the nerves themselves.
And why focus on these?
Because they're really important markers. Increased WMLs are linked to, faster brain aging, a higher risk of cognitive decline, and they can even be biomarkers for Alzheimer's disease pathology.
Okay, makes sense. And they also talk about mild cognitive impairment, MCI. Where does that fit in?
Right, MCI is crucial too. It's seen as this transitional stage. It's somewhere between the cognitive changes of normal aging and the more severe decline of dementia, like Alzheimer's.
So memory problems, maybe thinking issues, but not enough to totally disrupt daily life.
Exactly. Your cognition has declined noticeably, but you can still function independently for the most part. And it's really important to note, not everyone with MCI goes on to develop Alzheimer's.
That's a key point. Okay, so the study tracked people for 7 years, you said? That's quite a long time.
It is. This wasn't just a snapshot. It's a longitudinal study, which is a huge strength.
How did they set that up?
They used data from ADNI, the Alzheimer's Disease Neuroimaging Initiative. They started with 153 adults who were all cognitively healthy at the beginning.
Okay, starting from a healthy baseline.
Yes. Then they tracked them for at least 7 years. Over that time, some people, unfortunately, showed cognitive decline. So they ended up with two main groups.
Sorry.
Group 1, 85 people who stayed cognitively healthy throughout the 7 years. They called them the HC stable group. Healthy control stable.
Okay, the stable ones.
Group 2. 68 people who started healthy, but during those 7 years transitioned to that MCI stage you just discussed, the HC converters group.
The ones who show that decline.
Exactly. And crucially, they used MRI scans to measure the WML volumes in everyone. both at the start and over time. And they looked at how age, sex, education, and which group they were in related to those WMLs.
That long-term view seems really important for understanding progression.
Absolutely. It lets you see change over time, which is much more informative than a single point in time.
So when they started, these two groups, the stable ones and the converters, were they already different in obvious ways? Like, did the converters start out older or with more lesions?
That's what's really interesting, and it's a major strength of how this was set up. At the baseline, the very beginning, there were no statistically significant differences between the two groups.
Really? None?
None in terms of age, their years of education, sex distribution, or even the amount of WMLs they already had. Both groups started off looking pretty similar on these key measures while they were still cognitively healthy.
Wow. Okay, that is crucial. It means differences later on aren't just because they started differently.
Precisely. It strengthens the idea that whatever they observed later was related to the process of conversion or stability itself.
Okay, so the stage is set. We have these two groups tracked over 7 years. What did they find? What happened with the WMLs as people aged?
Well, connecting back to what we know generally, perhaps the least surprising finding was that age itself was the most significant predictor of how many WMLs people had.
Okay, older age, more lesions. That fits.
Yes. Both types, the hyperintensities and the hypointensities, their volumes increased as people got older. It just reinforces that, yeah, a lot of white matter change is tied to age-related processes, like changes in blood vessels and general neurodegeneration.
Right, standard aging processes.
Mm.
But the big question for this deep dive, education. Where did that fit in? Did having more education just mean fewer lesions for everyone? Was it that simple?
That's where the story gets, well, much more nuanced and really interesting.
Right.
They found that education, just by itself, did not have a significant main effect on WML burden across everybody at the start.
So more school didn't automatically equal fewer white spots on the scan for the whole group?
Not directly, no. It wasn't a straightforward protective factor for everyone in terms of the lesion load itself.
Okay.
But witty, and this is really the core finding they found, a significant
There's
interaction.
interaction between...
Between which group people were in stable or converter and their level of education.
Okay, interaction. What does that mean practically? How did education interact with being stable versus converting?
It means that the effect of education on WMLs was different depending on whether someone stayed healthy or converted to MCI. Education seemed to moderate that relationship.
Moderate. Okay, walk me through that. What did it actually look like for the converters?
This is the key takeaway. Among the people who did progress to MCI, the HC converters group having more years of education was associated with having a lower burden of WMLs.
So for the group on the path to decline, education was linked to less physical damage.
Exactly. It wasn't doing much for the WML load in the stable group, who were doing fine anyway. But for those who were vulnerable, who were showing that transition to impairment, higher education seemed to offer some kind of protection against accumulating that white matter pathology.
Wow, that's really specific.
It is. It suggests education isn't just helping people cope despite damage, which is the classic cognitive reserve idea.
Right.
This suggests it might be linked to less damage in the first place, specifically for those individuals who are actually at risk of decline.
So it's potentially influencing the pathology itself in vulnerable brains. That feels like a pretty big deal, a potential shift in how we view reserve.
It really is. It extends that traditional CR hypothesis. It's saying maybe CR isn't just about managing the symptoms of pathology, but maybe it's also, in some way, linked to reducing the amount of pathology itself.
How? What are the theories on how more years in school could translate to fewer lesions, especially for those at risk?
That's the million-dollar question, and the mechanisms are still being figured out. But there are some strong possibilities. One is enhanced brain plasticity.
Okay, the brain's ability to adapt.
Right. Education is linked to things like increased synaptic density, more connections between neurons and stronger networks, especially in areas vital for learning and memory.
Building a more robust network.
Exactly. Another possibility relates to that idea of brain reserve we mentioned. Higher education has been associated with things like increased brain volume and maybe even greater neural efficiency, just a more resilient physical structure.
Okay.
And then there's the idea of network flexibility. Education might equip the brain with more diverse or efficient ways to reroute functions, making it better at compensating even when some damage starts to occur.
So it's potentially changing the brain structure, its efficiency, and its ability to find workarounds. It's not just the facts learned.
Precisely. It's how the process of learning shapes the brain. But we also have to consider education often stands for more than just classroom time, right?
Yeah, that's true. It correlates with so many other things.
Absolutely. It's often a proxy for broader life experiences. People with more education are, generally speaking, more likely to end up in jobs that are cognitively demanding.
Right, jobs that keep you thinking.
Constantly problem solving, learning new things. And we know that occupational complexity itself is linked to better cognitive outcomes down the line.
So the job continues the brain training in a way.
You could think of it like that. And there's more too. Higher education often goes hand in hand with healthier lifestyle behaviors.
How so?
While statistically, higher education levels are often associated with lower rates of things like smoking and obesity, better health literacy, understanding health information, and often better access to health care.
Ah, okay, so lifestyle factors play a big role.
A huge role. The study mentions something called the brain battering hypothesis.
Brain battering, that sounds intense.
It does, but the idea is that maybe lower educational attainment could mean, on average, greater lifetime exposure to things like vascular risk factors, high blood pressure, diabetes, maybe more socioeconomic stress or adversity. And all those things could theoretically contribute to more battering of the brain's vascular system, leading to more white matter pathology.
So education might be protective, partly because it leads to a life with fewer of those risk factors.
That's definitely part of the thinking. It highlights how intertwined everything is: education, occupation, lifestyle, socioeconomic context. They all potentially feed into long-term brain health.
It makes separating out the unique effect of education itself really tricky.
It does. And that brings us to thinking critically about the study itself, its strengths and limitations.
Right. Every study has them. What stands out as a major strength here?
For me, the biggest strength is definitely that longitudinal design. Tracking people for 7 years as they actually transition from healthy to MCI, that's incredibly valuable.
Much better than just comparing separate groups of healthy and MCI patients at one time point.
Exactly. It gives you insight into the process, the progression. Also, they used rigorous methods like anatomical MRI biomarkers to confirm the MCI diagnoses, adding confidence to their group classifications.
Okay, solid methodology. But no study's perfect. What are the limitations we need to keep in mind here? What makes you pause?
Well, you touched on one earlier. A key limitation is using only years of formal education as the proxy for cognitive reserve.
Right, because reserve is broader than just school.
Much broader. CR is this complex thing influenced by your job, your hobbies, social engagement, learning new skills throughout life. Relying only on school years might miss a lot of other factors that contribute to resilience.
So someone with less formal education but a really complex job and active social life might have high reserve that isn't captured.
Potentially, yes. That's one issue. Another really crucial limitation is the ADNI cohort itself.
For people in the study.
Exactly. The ADNI cohort is, well, not very diverse. It's primarily highly educated, non-Hispanic white individual.
Ah. So can we generalize these findings to everyone?
That's the question. We need to be cautious. The relationship between education, socioeconomic factors, healthcare access, and brain health can look very different in other populations. Disparities in educational quality, not just quantity, also matter hugely. So these findings might not apply universally.
Good points. Context is key. Okay, so wrapping this up, this deep dive really does make you think differently about education, doesn't it?
Yeah.
It's not just about getting a degree or learning facts decades ago.
No, it really reframes it as potentially having this long-lasting biological impact.
Yeah, the idea that the act of learning, and maybe the kind of engaged life it often leads to, might physically build a more resilient brain, one better protected against pathology later on.
If you zoom out, yeah, it strongly reinforces this idea that what we do across our lifespan, maybe especially in those earlier formative years, could be building up this significant buffer against neurodegeneration decades later.
So the big takeaway for you, listening now, this study offers some pretty compelling evidence that cognitive reserve in education is a big part of, that might do more than just help you cope with brain changes. Particularly if you happen to be in a group showing signs of vulnerability. It suggests higher reserve might actually be linked to less physical white matter pathology, less damage.
It's a powerful idea.
It really is. It's a strong reminder that investing in your brain, through learning, staying curious, engaging with complex ideas throughout life, it might offer a very real, tangible, protective benefit against cognitive decline.
The data is certainly pointing in an interesting direction.
Which leaves us with a final thought, doesn't it? If formal education helps build this powerful reserve, what else counts? What other kinds of lifelong learning or cognitive engagement could give us similar, maybe even additive benefits?
That's the critical next question, right?
Yeah. How can we all, as individuals, as a society, better nurture and leverage this kind of brain resilience for everyone, regardless of where they started? Something to definitely mull over until our next deep dive.